Hello and welcome to Physics Teacher. Graphing g of x here in grade 11 functions can seem like a pretty daunting task. But as long as we know our parent function, in this case f at x, there are some very simple steps we can take to graph something that seems quite complicated quite easily. Let me show you. Let's get started. Alright, so the first thing we want to do is to understand the different transformations that can occur to a parent function. So we're going to go over each one, and I've created this very weird function right there, but I find that function very visually pleasing to be able to see those transformations. So the general form for a function is going to be, so here I have my function, don't worry about what it is, but f at x, but then a transformation function, let's call it g of x, is going to equal a times f of k times x minus d, all plus c. So we got four variables there, a, k, d, and c. So four things that we can do to this function. Let's see what each one of those actually does. So first, a. What happens if I increase a? Notice the function stretches. If I make a 2, look at what happened to the y value at this point. It went from 1 to 2. It doubled. So making a 2, we simply multiplied the y value by 2. As you can see, if I made a 3, we multiply the y value by 3. Well, what if a becomes negative? Well, then we get a reflection about the x-axis. But essentially, again, all we're doing, a is -1, we multiply the y value by -1, and we get our new transformed y value. That's all there is to it. So a deals with vertical stretches, compressions, and don't worry if it's a fraction. If it's 1/2, just multiply your y-coordinate by 1/2, and reflections about the x-axis. Okay, well, what does k do? K is right here inside of the function, multiplying by x along with this shift, which we'll talk about in a minute. What does k do? If I increase k, looks like I'm compressing it horizontally. If I were to make k2, well, our value gets halved. So we have to take our x value and divide it by 2, or divide it by whatever k is. If k is 4, looks like we went from 1 to 1/4, or -1 to -1/4. So all we have to do is divide the x-coordinate by k to figure out what the new x-coordinate actually is. Well, what happens if it's negative? Well, if it's negative, we get a reflection about the y-axis. But again, we're just multiplying our x-coordinate now by a negative number. That's all there is to it. So what does d do? Well, if I increase d, we see the function shift to the right. So having a positive value of d, for example, +3, moves our x-coordinate over 3 units. Now, in the equation, there's a negative. So if d is +3, remember, replace d with 3, and you get x minus 3. If d shifts to the left, you have a negative value of d, but if you replace d with -3, the double negative gives you x plus 3, something to always be aware of. Finally, what does c do right here on the end? Well, if I increase it, it looks like we have a vertical shift, upwards for positive values and downwards for negative values. So all I need to do is add that value of c to your y-coordinate to help you figure out what the new coordinate is. Now, if we have multiple different transformations happening at the same time, we are going to do it in this order. So we'll apply a and k first, and then we'll apply the translations d and c second. Okay? And you can get all sorts of fun shapes for our new functions. Now that we know this, let's go back and tackle that problem we saw at the beginning of the video. So what kind of transformations do we then have with this function g of x from its parent function? Well, a couple of things. Notice our value for a is -2. So what did we have to do to a again? We had to multiply the y-coordinate. Okay, so the y-coordinate we are going to multiply by -2. Then we also have this value for c. So c is -3. That's our vertical shift. So then we have to subtract 3 from our y-coordinate. So this is how we find our new y-coordinate. Well, what about this here? K. K is 4. Well, we have to take our x-coordinate and divide it by 4. And then we have a shift. So this is a plus here. So remember, the equation is x minus d, so therefore d would have had to have been -1. So we have to subtract 1 to get our new x-coordinate. So let's apply these transformations and translations to these 4 coordinates to figure out what they would be on our new graph. So 0, 0. So our x-coordinate, so 0 divided by 4, well, that's 0. Subtract 1, well, that's -1. Our y-coordinate is 0. Okay, multiply by -2, that's still 0. Subtract 3, well, it's -3. So there's our first point, -1 and -3. Next, 1 and 1. So our x-coordinate is 1. Divide by 4, so that's 1/4 minus 1. So that would be -3/4. Or if you like decimals, minus 0.75. Now our y-coordinate is 1. So multiply by -2. So that's -2. Subtract 3, we get -5. So that would be somewhere 1, 2, 3, 4, somewhere about here. All right, let's try the next one. So our x-coordinate is 4, divided by 4, that's 1, subtract 1, that's 0. Y-coordinate is 2, times by -2, that's -4, subtract 3, -7. So that would be 1, 2, 3, 4, 5, 6, right there. And finally, 9 and 3. So our x-coordinate is 9 divided by 4. 9, 4 is 2 1/4. Minus 1 would be 1 1/4. And our y-coordinate being 3. So 3 times -2 is -6. Minus 3 is -9. So 1 1/4 is about here, and then -9 would be about here. So this now looks like something like that. And then we can go ahead and throw that into Desmos just to make sure we're right, and look at that. Perfect. If you have any questions, let me know in the comments. I hope this video helped. And if any of you are taking grade 12 physics next year, for a limited time, you can download my whole course pack that I use for free in the description. Check it out, and thanks for watching.